Welcome to the Tech Insights podcast, where we delve into the cutting edge of technology and engineering. I'm your host, here to explore exciting innovations, and today we're diving into the fascinating world of vector processors with a specific focus on T1, a groundbreaking RISC-V vector implementation. Let's kick things off by discussing what exactly T1 is and where it draws its inspiration from. Now, T1 is not just any processor. It's modeled after the Cray X1 vector machine. Yeah, you heard that right. This machine was pretty iconic for its time. T1 aims to extend the capabilities of RISC-V in lane-based microarchitectures. Think of it as supercharging the architecture to handle more complex operations seamlessly. So, what really sets T1 apart? To start, it supports an impressive standard, ZV32F and ZV32X, while allowing for scalability with a VLAN and DLAN that can go right up to 64K. That's a lot of power available for developers and engineers. Imagine running intensive computations without hitting a bottleneck due to memory constraints. And speaking of bottlenecks, the architecture is designed to integrate efficiently with any RISC-V scalar core. This flexibility means that you can plug T1 right into existing systems, enhancing their capabilities without a total rewrite. The architecture includes some fascinating features too. It boasts lanes for operation, chaining abilities that let processes run simultaneously, and a smart load store unit, or LSU. And here's a fun tidbit. The core is designed with Chisel, a hardware construction language. It's akin to using a more fluid and expressive way to shape the architecture. It's like crafting your own tailored suit, but for silicon. Now, let's not forget about the thought process behind design choices in T1. It employs a design methodology that is quite interesting. Unlike commercial cores that lean heavily on complex predictions and buffering, T1 focuses on vector instructions. This means it can efficiently manage thousands of operations without the cumbersome overhead. Are you curious yet about how all this plays out in real-world applications? Let's talk more about the load store unit. It's engineered for high bandwidth to ensure that memory can keep up with the processor's demands. Wouldn't it be great if every device could talk to its memory without delay? T1's architecture tackles that. Moving on, I hear you're intrigued about the tech savviness, especially for those who love to tinker. T1 allows users to configure their processing lanes using a Pokemon analogy for different lane sizes. For example, a grass type could represent 32 DLN, while Dragon could crank it up to a robust 64K. It's a playful twist that makes system configuration feel a bit like a game, doesn't it? Now let's share some personal thoughts here. Have you ever struggled with configuring new systems? The T1 project aims to simplify that process. Developers can specify their requirements through intuitive commands, reducing friction in project setups. As we meander towards the finish line of our discussion, let's review some take-homes. T1 is built for efficiency and adaptability, hitting milestones with its vector processing capabilities while maintaining a straightforward design philosophy. It's a bridge to the future of RISC-V with features that prioritize bandwidth, flexibility, and ease of use. And to wrap it up, I'd love to leave you with this thought. How might systems like T1 change the landscape of processing power for future applications? Perhaps in AI, data science, or even gaming. Thank you for listening to today's episode of Tech Insights. Stay curious and keep exploring the world of technology.